So in this video, we're going to look at a couple of examples of quantitative force diagrams where we're at an angle. So in this first one, we're going to try to determine the force of friction acting on this student that's balancing on one leg and the size of the magnitude of the normal force. Okay, so of course the first thing we're going to do is draw a force diagram. Okay, so I'm going to start with the force of gravity, right, on the person, right? So I've got my force of gravity. Of course, I've got my normal force. Okay. And I can take my force of gravity and divide it, kind of break it into, or think about it as its two components, right? The force of gravity in the x direction and the force of gravity in the y direction. And since the student's not moving, my net force must be 0. So there's another force here, and that's your force of friction. Okay? So those are the forces that I have involved here. And let's think about the ones that are the same in magnitude. So the normal force and the y component of the force of gravity would be the same. And the force of friction and the magnitude of the force of gravity in the x direction would be the same. Okay, so you want to start by writing out, statements for the x direction. Okay, so the force of gravity in the x direction is the same magnitude as the force of friction. I'm just talking about magnitudes here. Obviously, one is positive and one is negative. And then the force of gravity in the x direction is going to be Fg, right? And here's my 30 degrees, and we're the opposite, so that's going to be the sine of 30 degrees, okay? And that will equal my force of friction. So the force of gravity, all right, so force of gravity is mg, and we've got a 100 kilogram student, and times 10, so 1,000 newtons. So I'm going to plug this in. 1,000 newtons times the sine of 30 equals your force of friction. So the force of friction is going to come out to be 500 newtons. Okay, so we can use this relationship, right, the sine of the opposite here, so the sine of 30. So similarly, we'll do this to find the magnitude of the normal force, right? So the magnitude of the normal force is equal to the magnitude of the force of gravity in the y direction. Again, the normal force is positive and the y component of the force of gravity is negative, so I'm just talking about magnitude here. Okay, so this is going to be the force of gravity times the cosine of 30. Okay, because when we look at 30 degrees, this now is the adjacent. Okay, so we know the force of gravity again is 1,000. So cosine of 30, this comes out to be 866 newtons. Okay, so we found the force of friction and we found the normal force really just by knowing an angle and the mass of our balancing student. So now we're going to take a box that's being attached to a ceiling and a wall by two rods. Okay, and what we want to do is just let's just see what we can figure out here. What can we calculate based on everything we know? All right, so let's start with a force diagram. All right, so obviously we've got a force of gravity. Okay. Obviously, we have a force of tension right here, and then there's another force of tension right here. I'm going to call this Ft1, I'm going to call this Ft2, and of course we can think about this in terms of its components, right, because it's at an angle. Okay, so this is Ft1 in the x direction, this is Ft1 in the y direction, and this here is T1. So I could kind of move that over there. All right, and this is going to be a 30-degree angle, right? Because this was 60, so that'll be 30. Okay, so what are some things that are going to be the same size, right? Well, the y component of this tension and the force of gravity, okay, and the x component here, and the second one there, okay? So if we write things in terms of the horizontal direction, okay, you want to think of things horizontal and then vertical, or in either order. But the force of tension 1 in the x direction is the same as the force of tension 2, okay? Again, just magnitude. Obviously, one is positive and one is negative. And since we're looking, this is the sign, the opposite. This is going to be Ft1 sine of 30, and that will equal the force of tension 2. And then in the vertical direction, right, I know that the force of gravity is equal in magnitude to the force of tension 1 in the y direction, which is equal to the force of tension 1 times the cosine of 30. Okay, right, because now we're at the adjacent. Okay, well, we know the force of gravity, right? That's mg. So that's going to be 100 times 10, or 1,000 newtons. So I'm going to go ahead and plug that in here for the vertical, because that looks like I know the most here. So 1,000 newtons, right, equals the force of tension 1 times a cosine of 30. So divide both sides by the cosine of 30. Okay, and we're going to get the value for Ft1, which is this angled one. Okay, and if you do that out, you're going to get 1,155 newtons. And then we can come plug that in over here, right? 1,155 newtons times the sine of 30 will equal the force of tension 2. So if you multiply that out, you're going to get 578 newtons. Okay, so what we've done is we figured out that this is 578 newtons, and that this one here is 1,155 newtons. So by setting it up and comparing all your vertical components and your horizontal components, you can calculate pretty much everything. All you kind of need is a mass and an angle. And that's it.